Hi there, Math 100. This video will be on combining and simplifying radicals that contain variables. So the first thing I want you to see, it says in order to add or subtract radicals, the radical must have the same index and the same radicand. So I provided a picture over here so you can see what the index is. The index is that number right here. So that number right here is 3, for example. 3 is the index, and the radicand is just the number under the radical. So again, the index is the number here, as you can see in this little v part here. If you don't see a number there, that's actually understood to be a 2 there for square root. So if you don't see any number, it's considered to be a 2. Alright, let's begin. Simplify. Here we have 3 radical 8 plus 2 radical 18 minus 4 radical 2. As you can see here, the index is 2, or considered to be 2, because there's nothing in this little v part here. So we actually have the same index for all of these. However, we do not have the same radicand. But in order to add or subtract radicals, the radical must have the same index and the same radicand. Therefore, I'm going to break down 3 radical 8 plus 2 radical 18. And then we're going to subtract from 4 radical 2. So let me show you how. So I know I can break down the square root of. We have 3 times the square root of 8 does have a perfect square factor in 8, which is 4. So we can break down 8 as 4 times 2. Plus 2 times the square root of 18 has a perfect square factor as well, which is 9. So 18 can be broken down as 9 times 2. Then we have minus 4 radical 2. The square root of 4 here is 2. So we're going to write down 2 here. But you can't find the square root of 2, so you leave that 2 under the radical. The square root of 9 here is 3, so it comes out of the radical. And of course that 2 stays under the radical. And you have 4 radical 2. 3 times 2 is 6. Then you have radical 2 plus another 2 times 3, which is 6 times radical 2 minus 4 radical 2. Now what you see is you have the same index and the same radicand. You have the square root of 2, square root of 2, and square root of 2. So you treat these radicals just like terms. Alright? You can add the coefficients in a sense, right? 6 plus 6 is 12 minus 4 is 8. So your final answer, because 6 plus 6 is 12 minus 4 is 8 radical 2. Alright, next we have 3 radical 20 minus radical 5 minus 2 radical 45. As you can see, we have the same index because all of these are square root symbols. However, we don't have the same number under the radical, so let's simplify to see if we can get the same thing, the same number under the radical, which is called the radicand. So 3 times the square root of, can we break down 20? We can. There is a perfect square factor in that, which is 4. And I like to write my perfect square factors or my perfect cube factor first, so that you'll see that it's on its way going out of the radical. Minus, can't break down radical 5, so it stays as radical 5. Minus 2 times radical 45. Now 45 has a perfect square factor, which is 9. So 9 times 5 is 45. Now let's break it down. Square root of 4 is 2. So 2 will be taken out of the radical. We can't do anything with radical 5 since it's already in its simplified form. But as you can see here, square root of 9 is 3. So you can take out a 3. So it'll be 2 times 3 radical 5. Now what you're left is 6 radical 5 minus a radical 5 minus 6 radical 5. Couple ways you can do this. One way is to look at this as a 6 minus a 1. Most people miss that this is considered to be a 1 here, so don't miss that. 6 minus 1 is 5 minus 6, which is another negative 1. Radical 5 or just plain negative radical 5. So both are equivalent to each other. You could have also looked at this as 6 radical 5 minus 6 radical 5. I don't know if you can notice this, but you could have canceled those two things out and you would have been left with negative 1 radical 5. Alright, next we have 3/8 times radical 96. So you have to figure out what perfect square can go into 96. Yeah, so 16 times 6 minus 2/3 times, and you use your context clues. So if 6 is in there, maybe 6 is in 54 as well. So 9 times 6 works. Alright, so now let's break this down. We know that square root of 16 is 4. We know the square root of 9 is 3. So we can take those numbers out. 3/8 is going to be multiplied times a 4 now, since square root of 16 is 4. And 2/3 will be multiplied times 3 now, since the square root of 9 is 3. Now what is 3/8 times 4? This is when you're using your knowledge of operations on fractions. This is multiplication, so you can really break this down. This is like a 1 here. So if y'all want to look at it as a 4 divided by 1. 4 goes in 8 twice. 3's can cancel out here. So what we have left is 3/2 radical 6 minus just a 2 left radical 6. So we have the same radicals. Square root of 6, square root of 6, so that means we can combine these two radicals. We're subtracting, and we're subtracting 2 from 3/2. Again, you have to use your knowledge of fractions. So what do you need in order to subtract fractions is the question. So definitely you need LCD, right? So the LCD is 2. So let me do this off to the side here. We know that 3/2 minus 2/1. LCD is 2, so I need to multiply that times 2. That would give me 3 minus 4/2, which is negative 1/2. Therefore, the final answer is negative 1/2 times radical 6, or if you just want to write it as negative 1 times radical 6, which is negative radical 6/2, these answers are equivalent to each other. Alright, let's move on. Next, we have 5 times the cube root of 2. So that's not 5 cubed. That is a little close to that 5, but it's actually the index 3. So you see the index 3 in all these. So we have the same index, however we don't have the same radicand. So let's see if we can break this down. It's 5 cube root of 2 minus 2 times the cube root of what? Since we're dealing with 3 as the index and we're dealing with cube roots, we have to find the perfect cube of 16. So what is a number times itself that will give you 16? It's actually 2 times 2 times 2 is 8. So 8 times 2 is 16. So 8 is a perfect cube, minus 6 times the cube root of 3 times 3 times 3 is 27, so I can break this down as 27 times 2. So we have 5 cube root of 2 minus 2 times, since the cube root of 8 is also 2, a 2 will come out of the radical. And you're still left with this 2 right here under the radical, but a 2 came out. Minus 6 times the cube root of 27 is 3, so a 3 comes out. And you still have the cube root of 2 left. So that's 5 cube root of 2 minus 2 times 2 is 4. Cube root of 2 minus 6 times 3 is 18 times the cube root of 2. 5 minus 4 is 1. 1 minus 18 is negative 17 cube root of 2. For these type of problems, it's best to have a list out of all your perfect squares and all your perfect cubes, so you can refer back to it. So you can just write down the numbers once you realize you have to find perfect squares and perfect cubes. So that's it for my first video. Stay tuned for my next video.